In this video, I would like to show you where the repeat data comes from in joins and how we can plan for that. So when you're planning a join of two relations, how can we know in advance whether the rows from each relation can appear at most once or more than once in the result? Simple answer is that if the entire identifier of a relation is used in the match, then each row of the other relation can only appear once in the result. Otherwise, each row could appear multiple times. I'll go over some examples of this. In the last video, we went through this sequence of times, filter, and reduce, and we used the CID of the good achievement and the CID of creature. Those were the columns we were matching on. And in this example, we did not have any repeat data, but that was a bit lucky. So in this case, let's suppose we show this data and the stakeholder replies, okay, so that shows me the skill code that each creature is good at. Show me each creature's poor skill now, or otherwise show me each skill's poor creature. Do you see any problems in this request? How can we notice the problems in this request? So let's move to calculating the results. So let's suppose we look at the poor achievements of creature. We can calculate this the exact same way we did for good achievements. We can start by looking for score of 3, which we know means poor, and we can copy those over. There's really only 4 of those. And then we can copy the headings for creature. Now this time, instead of actually doing a full times operation and then a filter, we can sort of mentally do both at the same time. So we can loop through the values that we have and do the matching on the fly. And I've already done that by, to some extent, by eliminating all but the 3s. But then what we specifically want to do now is to not have to repeat these 4 either by looking for matches. So we're going to look for 1 and 2 and 5 in the result. And we can see that we have creature ID 1 actually appearing twice because we have CID of 2 times. Then we have creature 5 and creature 2 in here. And then finally, so this was what I've just done here was the combination of the times and the filter. And finally, with the reduce, we remove this dull duplicate column and are left with simply poor achievement with its creature data. Now, unlike last time, we have some repeats here. We have, and specifically it's here, we have the creature 1 data repeating twice. Why is this? Well, it's possible to have these repeats because the matching that we were doing on was not the entire identifier of achievement. It was only the CID part and not the S code. And you can see that within the CID column, you have values like number 1 that repeat. 1A and 1E and 1Z cannot repeat, but 1 can repeat and E can repeat individually. And so if you're only matching on part of the identifier, then the rows of the other relation can match against those multiple times, and that's what's happened here. The problem can get worse because in this case, we were at least still able to take a base of achievement and end up with a result that was still a base of achievement. Let's look at a case where we do something different, where we match on some non-identifying data. You can match on any column you want, actually. And let's suppose that we take one of the extensions of the Tiny database that includes town data. We have creatures that each have a reside town. Town IDs reference the town relation here. And skills have origin towns. And then we can do a join here. We could say, let's find out the skills that originate in the towns that each creature lives in. So to do this, we can again copy our columns. We can look for matches. And so I can sort of look ahead here and see that not all of these are going to match. I have town ID B, T, M, and P. EM for Embarrass, Minnesota. EM doesn't match any of the reside towns, and some of these towns, like A for Anoka, don't match any of the skills. So we can sort of look ahead here. We can see that P does match for Philly. Bannon lives in Philly. And as far as skills, we have gargling in Philly. So there's one match for Bannon. Next to Myers, we see that Myers is Anoka. There are no matches. B for Bemidji, there are actually two matches. So NEF3 actually matches against two different skills, swimming and floating. Continuing on to number 4, Chaska, no matches. Number 5, D for Duluth, no matches. 6, Carlos, P for Philly again. So we're going to match the gargle row again here. 7, in Hollywood, no matches. And finally, 8, Godzilla in Tokyo, of course, does match the sinking skill. Now we can see again what happened here. Creature 3 data residing in town B has repeated, and also the gargle skill has repeated. And so this is even a trickier situation than the last one, because in this result, we have no single column that has unique values within it alone. So there is no way for us to take this concept that we had before, where we had a starting relation and then try to join more data onto that relation, because at a minimum, you're going to start to expand some rows. We can't, for example, reduce this down to not being the identifier and having only CID, because this is going to violate that identifier. We have to keep S code in the identifier here. So this has to stay a pair. We could say this is a creature skill pair. What kind of creature skill pair? Well, it's the cases where it's the same town, or really the resides in the origin town creature skill pair. That's the kind of data we're looking at here. So a couple of things have happened here. We've lost certain rows, like Miska is not in the result. We've lost certain rows. Walk on Water is not in the result. So no matter which relation you're considering to be your start, you've lost some of the data because it didn't match anything in the other relation. And in addition to losing rows, you have duplicates. You have repeats. How can we plan for all of these problems? So let's go back to good achievement and creature. And in order to think through all of these things at once, we have a bit of a framework to work with. So we're going to select these two that we're going to join with and start up a match join. There's two things that we're going to decide here. We're going to decide what we are trying to get to as an end base, which is going to be the relation that we attach to the peak. The peak represents the relation for which the base is going to pass through. So here what we're saying by putting the peak on good achievement is that we want this to be some kind of achievement as the base. We're declaring that this way. So that's one thing we're choosing that's based on our goals. We're trying to get to a situation where we have achievements and we have creature data attached. If we had flipped this, we would be saying that we want this to be some kind of creature for each row. So we're going to flip it back this way and work toward achievement as a base, some kind of achievement. And the other thing we're going to do is we're going to choose how we're going to do the join. In this case, we chose to do it based on CIDs. So we're going to say we're going to use the CID of the A relation, which is the peak. A means peak and B means off peak. So we're going to use the CID from both of those. And those are really the points of decision. Now, where these things come to meet together is we're going to fill in these parentheses with a letter from the mnemonic of demons. And really, it's going to be E and M for exact and more matching, or S, O, and D for some overlap or disjoint. What are we doing here? What we're doing is we're going to say, given the selection of CID as our match, how does that choice relate back to the identifier of the relation we started with? In this case, CID is only some of the identifier of good achievement, so we're going to use S. And CID is exactly the identifier of creature, so we're going to put an E for exact. This fits the shape of what we call a not symmetric A match join. So that's this first upper left column here. You can see it's pretty similar to the example we have. We have AID of S, BID of E. That means that from the A relation, we're taking some of its identifier to do the match, and from the B relation, we're doing exactly its identifier. And that's a pretty standard, simple join pattern. This is a pretty normal join. This is called a not symmetric A match join. It's not symmetric, meaning that it matters which one we connect it to. Remember, if we flipped it, the meaning would be quite different. We would be saying we're trying to get to some kind of creature. That's what makes it not symmetric. And we call it a not symmetric A match join to mean the fact that we are going to have an A relation for which we're passing the base through on from achievement to achievement. So these letters are intended to be a way for you to think through and document explicitly what it is you're doing. What happens if we flip this? If we flip this, this is actually not accurate anymore because this creature is now on the A side and this is on the B side. So we need to actually write an E here. And notice the arrows are changing as I do this. And we need to write an S here. Now what's happened? We flipped this to say that the E and the S are the other way around so that the A relation has an exact match and the B relation has a not exact match. There's some other scenarios that could come about here. And what we're finding out here as we play with this is that this opposite scenario does not work. It doesn't work because we're not going to be able to hold the base. Let's try this. So if we start with creature and then we try to attach achievement, we're going to do this the other way around. We're going to start with creature and try to attach achievement. So for creature 1, what are our matches? We get multiple matches. Even if we take, well, let's take poor achievement. We get 2 matches. So right away, you can see that as I do this match, I'm going to need to repeat Bannon because Bannon matches 2 different skills. And by repeating, I've violated my identifier. So that really doesn't work. It worked the other way around because we started with an identifier that would permit those repeats. So this is a device for checking whether what you're doing makes any sense. Another scenario you can have is a symmetric either join, where you have exact and exact. So here we have CID and CNAME of person creature, CID and swim score of swim creature. The point is that we have CID and something of something creature, and we have CID and something else of something else creature. And when we do this, this can be an exact match on both. This is called a symmetric either join because we have 2 different relations that both are identified by only a CID. And it's symmetric because it doesn't matter which is on the left and which is on the right. And so we put them on the peak like this, both of them, to indicate that eitherness, that it really doesn't matter. It may affect the results of which columns you put on the left and the right-hand side of the result that you write, but in relations, order doesn't matter. So by putting E and E, we're in the symmetric either category, and this should also be some kind of creature to say that this is the same base. We expect this to be the same base coming in. Creature base and a creature base are going to join at the peak, and that is again going to represent the base of our final result. We're going to get some kind of creature. Symmetric pair is interesting. We're doing this example with reside town and origin town. To represent that, we can take creature and skill, and we can join using the reside town ID and the origin town ID. And this will be a disjoint of both of those. D meaning that's a disjoint set, an unrelated and separate set of columns from the identifier. So there's absolutely no overlap with the identifier. And now the match join changes to a house shape. Why is it a house? A full house shape. With the full house, what we're doing is we're creating some kind of a pair. So we're creating some kind of a pair here. In this case, it's going to be a creature skill pair, some kind of creature skill pair. By declaring it as disjoint on both sides, we know that we can have multiple matches on both, which is what we discover here. We have multiple creatures that match against the origin town of B because, I'm sorry, multiple creatures that match against the reside town of Philly, and multiple skills that match against the origin town of Bemidji. And so with those multiple matches on both sides, as we found out, there was no way to identify the result by just one column. So we have to keep it a pair, so it's going to stay a pair. So this takes us to our symmetric pair scenario where we use a full house shape. Finally, there's a not symmetric either shape. So in the symmetric either, we had AID of E and E. You can also get it from M and M, which means taking the full identifier plus additional columns to do the matching. You get the same result either way because it's including the whole identifier, so you can only match once per row. The not symmetric either case is interesting because in that case, we're actually doing an E on one and an M on another. Let's look at this example. We're going to match on the CID and the S code of achievement. Remember, A is the peak and achievement is on the peak. And we're going to use the CID and the least aspired to S code of creature. So we're going to use exactly this, and this is going to be CID and S code. And we're going to use more than the identifier of creature. We're going to use CID and the least aspired to S code. So we're using exactly the identifier here, we're using more here. Now this is still a one-to-one because we have a CID here, and you can only have one creature for any given CID. And we have both CID and S code here, and you can only have one achievement for each of those. But now we're including a little more in this match in order to do an S code versus S code match. Here the match join changes to have a dotted line, and that's a separate symbolic indicator of the not symmetric either shape in particular. This is going to give us, what's the base? Achievement. It's going to be some kind of achievement, that is, because we have achievement on the peak. But there is an etherness to this still, because we could flip this and we could still do the same operation. But now we would be saying that we're getting some kind of a creature out of the result. And unlike the other scenarios, we're able to change the base here based on flipping this. But we still have that option. So that covers the 4 shapes here for match joints. And so in the upper left here, you can see this is a one in many case, not symmetric A. You have an S or an O or a D on top, not on bottom. That would be backwards and that would be bad. And an exact or more match on the bottom. AID of SOD, AID of E or M. So this is a one in many match. There's 2 one-in-one matches, the symmetric either and the not symmetric either. And you get slightly different options depending on that. For the symmetric either, you always get the exact base of your 2 inputs passing straight through. With not symmetric either, you get a choice of your base between the peak and the off-peak. You can choose which one gets to be the peak and the off-peak. And with symmetric pair, you don't get to have the base of either of the input relations because you're doing an S, O, or D match on those columns on both inputs. So there is no one-to-one matching. It's all many-many matchings. That's why this says many and many. If we cover natural join, that's basically a special case of not symmetric A also. Looking ahead a little bit, that all seems like a lot. In SQL, if you're familiar with it, you may know that really the only options you have are inner join and outer join, where outer join can be fully broken down into left, right, and full outer join. And then sometimes you'll use what's called a cross join. In my experience, more than half of the time we're using inner join, and most of the rest of the time we're using a left outer join. Usually don't even need to choose left or right because you're in control of that. And full gets into pretty special cases and cross join gets into pretty special cases. So it seems like there aren't that many real options when you get down to SQL. So why are we doing all of this breaking down? What we're trying to do here is apply more of the relational concepts of being in control of your base and understanding when the one and many stuff happens. If you just use inner join, you can get those repeats and you can get the missing rows, and that can be a surprise. And what we're trying to do here is understand that in advance. The way that John Carlos has inner join broken down is between match join and range join being in part 5, which we may not get to. With match join, we're doing this exact matching. CID is equal to CID. Exactly, this value is equal to that value matching. That's an entire category that is worth studying because of all the consequences that we covered in this video. And those can be broken further down into these columns or in these options on the right that I covered: not symmetric A, symmetric either, not symmetric either, symmetric pair. And with range join, what you're doing, and this will be an entirely separate set of videos if I get to them, we'll be doing not exact comparisons where you're taking a number, for example, a score, and comparing it to a range of acceptable values or allowed values, saying, for example, greater than or less than a certain threshold, then it matches, that kind of matching. All of those are options that you can pass to a SQL inner join. But Carlos's textbook makes a distinction between those, and we put a lot of attention on match join to understand when do these ones and manys come about. We also will look at outer join, which also has its own version of range, so you can have range outer join, which is another separate topic. And we don't distinguish between left and right in relational algebra. We're always in control of which one has the base based on the way that we orient the house shape in this textbook. There is a both outer join, which is effectively the same as the full outer join. And then with cross join, that's just a times operation. So at this point, what I'll be looking for you to understand better are these different categories of match join that I have on the right-hand side. You can refer to the textbook to find lots of examples of good, here's not symmetric A match joins. So what you can do is you can take the examples listed here and try actually doing them. Use a spreadsheet, use a piece of paper, see if you can take the columns listed here and do the matching and see what happens. And you'll start to see the effects of the sum, overlap, disjoint, the more, the exact. You'll start to see those come out and understand how they relate. Also, the quick join or the match join quick reference is a file that I have on Canvas that you'll find that lists this set of options for match join that you can refer to. And that is all for this video.